Picture this, a person standing all alone on a vast dark plain, somewhere far from the bright, dazzling lights of civilization. Directly overhead, the silvery ribbon of the Milky Way stretches majestically, like a celestial silk scarf studded with a myriad of diamonds. This is our home galaxy, appearing as an endless swarm of stars, pierced by the mysterious shadows of interstellar clouds and obeying the invisible forces of gravity that govern all its complex motion. But what exactly lies hidden behind this breathtaking spectacle? How does our galaxy appear to us when viewed from within? We live within a giant star system that extends into space for a full 100,000 light-years, a truly incredible distance. Within these vast limits, according to the most approximate estimates, there are about 400 billion stars, each a unique and unrepeatable celestial body. Among this countless multitude, our Sun, which gives life to our planet, looks like just a tiny grain of sand in the boundless ocean of space. Here we find colossal giants whose radiance exceeds the brightness of our native star by millions of times, and tiny, barely visible dwarf stars, barely glowing in the cold void. And there are stars whose fate has already been sealed. They are slowly but surely burning out, tragically exploding in dazzling supernova flashes, and leaving behind mysterious and incredible objects that stir the imagination of scientists. However, the stars themselves are only a small part of this giant, complex structure called the Milky Way. Within this majestic galaxy are millions of star systems, each possibly possessing its own planets orbiting distant suns. In addition, you can find huge dust lanes serving as a cradle for the birth of new worlds, and the colossal gravitational influence of dark matter, without which our galaxy simply could not exist in its current form. At the very heart of the Milky Way lurks a supermassive black hole, a mysterious object whose mass exceeds that of the Sun by millions of times, and around it, as if in a cosmic dance, the entire galaxy revolves. Our modern understanding of the cosmos has been made possible by the impressive achievements of science and technology. For example, the Gaia Space Telescope, like a tireless cartographer, measures the position and speed of stars, creating the most accurate and detailed map of the Milky Way in human history. And the James Webb Space Telescope, equipped with unique instruments, is able to look through dense clouds of dust and see with its own eyes the birth of stars and planets in the infrared range, which was previously simply impossible. Radio telescopes, like giant ears, pick up weak signals coming from the most remote corners of the galaxy, recording mysterious bursts and detecting giant clouds of interstellar gas holding many secrets. But despite all these achievements, a significant part of our galaxy remains unexplored territory, full of mysteries and questions awaiting answers. We do not yet know everything about the structure of the Milky Way's arms, about the history of this galaxy's collisions with other galactic neighbors, and about what amazing and diverse worlds are hidden among the billions of exoplanets scattered throughout the galaxy. So, now begins a fascinating journey through the expanse of our home galaxy. In our minds, we will peek at the nearest stars, fly through multicolored gas clouds, observe dying stellar giants, and try to get a little closer to understanding what awaits our galaxy in the distant future. This exciting journey beyond the solar system begins with Alpha Centauri, the closest star system to us, located at a distance of 4 37/100 light-years. This distance is equivalent to approximately 26,430,000,000,000,000 kilometers, which is a truly astronomical figure. If it were possible to travel at the speed of light, the journey to Alpha Centauri would take only 4 years and 4 months. However, even the fastest human-made spacecraft, the legendary Voyager 1 probe, would take an incredible 70,000 years to cover this vast distance. But to study these distant stars, it is not at all necessary to travel there on a spacecraft. Modern telescopes are already lifting the veil of secrecy over the nearest cosmos, And the more data we receive, the more new mysteries arise before scientists. When viewed from Earth, Alpha Centauri appears to be just one bright star. But in reality, it is two stars gravitationally bound and orbiting a common center of mass. These two stars, like cosmic twins, revolve around each other, completing a full orbit in 80 years. The distance between them is constantly changing, varying from 5 5/10 astronomical units to 35 astronomical units. As you know, an astronomical unit is understood to be the average distance from Earth to the Sun. If a person were to find themselves in this star system, their world could be lit by two suns at once, which would be a completely unique sight. One of these suns would be bright and hot, while the other would be slightly dimmer and softer. They could appear alternately in the sky, creating bizarre double shadows, or one star would shine during the day while the other would remain visible even at night. Alpha Centauri. A is approximately 10% larger than the Sun and 20% brighter. If Earth orbited this star, the day on our planet would be slightly brighter and warmer. Alpha Centauri B, on the other hand, is 10% smaller than the Sun and approximately twice as dim. If our planet were near this star, its light would seem softer and warmer, and the daytime sky could take on a pleasant golden hue. According to some scientific models, one of these stars may have a planet similar in size to Earth and located in the so-called habitable zone, where the existence of liquid water, and therefore life, is theoretically possible. So far, this interesting assumption has not received experimental confirmation. But the most intriguing and mysterious object in this star system is rightfully considered Proxima Centauri, a small and dim star that is the closest to the Sun in the entire vast universe. Although Proxima Centauri may seem like a lonely star, it is not really an independent object. It is part of the Alpha Centauri system, just located much farther away from its bright stellar companions. If it were possible to see its orbit, it would appear as an elongated ellipse, along which Proxima Centauri performs a slow and graceful dance around two larger and brighter stars. The distance from Proxima Centauri to the main pair of stars is simply enormous, more than 10,000 astronomical units, which, as you remember, is 10,000 times the distance from Earth to our native Sun. But despite this remoteness, Proxima Centauri is still held in the gravitational embrace of this system, obeying its laws. It completes a full revolution around its stellar companions in a colossal 500,000 years, which means that its orbit has changed by only a negligible fraction of a percent in the entire history of humankind. Proxima Centauri is a small, dim, and relatively cool star whose size is approximately 7 times smaller than the size of the Sun, and its mass is 8 times less than its mass. Its luminosity is so insignificant that it can be compared to a barely noticeable candlelight in a huge, dark hall. If, by some miracle, Proxima Centauri were in the place of the Sun, the Earth would turn into an icy and lifeless desert bound by eternal cold. But despite its apparent weakness, this star exhibits amazing activity. It regularly emits powerful flares into the surrounding space that can exceed its normal brightness by thousands of times, representing a truly impressive sight. If the Sun behaved in this way, it would probably destroy all forms of life on Earth, turning our planet into a scorched and lifeless desert. Nevertheless, Proxima Centauri has a confirmed planetary system, which makes it even more interesting for researchers. Proxima b is a rocky planet that is approximately 30% larger than Earth in size and 20% more massive. It is located very close to its star, only 15/100ths of an astronomical unit, making it Proxima Centauri's neighbor. This distance is approximately 20 times less than the distance from Earth to the Sun. Due to its proximity to the star, a year on Proxima b lasts only 11 Earth days, which is a record-short orbital period. However, Despite such a small distance, the star shines quite dimly, and its energy reaches the planet in an amount sufficient to maintain water in a liquid state. This means that Proxima b is in the so-called habitable zone, where life in one form or another could theoretically exist. But there is one serious problem. Due to its proximity to its star, Proxima b is tidally locked. This means that it always faces the star with the same side, just as the moon always faces the Earth with one side. One half of the planet is constantly flooded with the bright light of the star, which can lead to its heating to high temperatures. There is possibly a molten surface covered in solidified lava. The other half of the planet, on the other hand, is plunged into eternal night and bound by frost, where the temperature can drop below 200 degrees Celsius. However, between these two extreme zones, a narrow twilight region might exist, where temperatures remain moderate and potentially suitable for life. If the planet has an atmosphere, it could redistribute heat and temper the climate, creating more favorable conditions for diverse life forms. But Proxima Centauri, as mentioned, isn't the friendliest star. It regularly emits powerful flares that could strip away a planet's atmosphere, leaving it vulnerable to harmful cosmic radiation. Scientists don't yet know if Proxima Centauri b has managed to retain its atmosphere, or if its surface is a lifeless, radioactive wasteland, inhospitable to any known life. Besides Proxima Centauri b, this star system hosts another planet called Proxima Centauri c. It orbits 10 times farther from the star, at a distance of 1.5 astronomical units. Proxima Centauri c is approximately 7 times more massive than Earth, suggesting it could be a very large super-Earth composed of rock and metal, or a mini-Neptune with a dense and massive atmosphere. Since this planet receives minimal heat from its star, its surface is likely covered in perpetual ice, concealing an icy crust beneath. Yet, there's a possibility that deep oceans of liquid water might lurk beneath the ice, similar to what we find on Europa and Enceladus, Jupiter's and Saturn's moons in our own solar system. Also, according to some unconfirmed data, this planet might possess a ring system composed of icy blocks and dust. In 2022, astronomers discovered another planet in this system named Proxima Centauri d. This planet is about 75% the size of Earth, making it one of the lightest exoplanets known to science to date. It orbits the star only 4 times farther than the Moon orbits Earth, and its year lasts a mere 5 Earth days, an incredibly short orbital period. It's likely a scorching and lifeless world, receiving excessive radiation from its star and unfit for any known forms of life. Since Alpha Centauri is at a record-breaking proximity to our solar system, it's slated to be the destination of humanity's first interstellar probe, which will have to traverse immense distances and reach another star system. The ambitious project called Breakthrough Starshot proposes using a powerful laser acceleration system capable of propelling tiny spacecraft to tremendous speeds and sending them on a journey to Alpha Centauri. If all goes according to plan, approximately 20 years after launch, we will see the surface of planets orbiting another star for the first time, which will be a real breakthrough in space exploration. For now, humanity can only dream of a real journey to the stars. But we already know one thing. If humanity ever leaves the confines of the solar system in the future, its first target will be Alpha Centauri, this close and alluring star system. Leaving the Alpha Centauri system behind, we mentally venture deeper into interstellar space, where silence and darkness reign. This time, our journey takes us to a solitary star, devoid of bright companions and long concealed from the eyes of earthbound observers. This is Barnard's star, located 6 light-years away and the second closest star system to the Sun. If one could accelerate time and observe the night sky over several centuries, we would see Barnard's star slowly but surely shifting against the backdrop of distant and stationary stars, like a cosmic wanderer moving along its own path. It truly traverses the galaxy at a tremendous speed, reaching 90 kilometers per second relative to the Sun, an incredibly high rate. Currently, it resides 6 light-years away, but it's gradually approaching our solar system. In approximately 10,000 years, it will be 3 75 light-years away, surpassing Alpha Centauri and becoming the closest star to the Sun. At that moment, it will rightfully earn the title of the Sun's nearest stellar neighbor. However, its primacy will be brief and fleeting. Millions of years later, it will once again begin to recede, yielding its place to another star, which will assume its position as the closest neighbor. Despite its proximity and incredible speed, Barnard's star is remarkably faint and unremarkable. It emits only 3% of the luminosity of our Sun, and its diameter is a mere 50% of the Sun's diameter. If it were to somehow replace our native star, the entire solar system would plunge into an eternal, icy darkness, where no life could exist. Interestingly, Barnard's star is far older than the Sun. Scientists estimate its age at roughly 9 or 10 billion years, an immense duration. This implies it formed in the early stages of the Milky Way's history, long before the emergence of Earth and the solar system's other planets. This makes it one of the oldest known objects in our stellar neighborhood, of great interest to researchers. But even this ancient and dim world harbors a planet, making Barnard's star system the focus of intense astronomical scrutiny. In 2018, astronomers discovered a planet called Barnard's star B, which is approximately 3 5/10 times more massive than Earth. It is one of the closest known exoplanetary worlds to us, making it particularly interesting to study. It orbits its star at a distance of 6/10 of an astronomical unit, roughly corresponding to the distance from Venus to the Sun in our own system. However, Barnard's star is so dim that even at this relatively short distance, its planet receives very little heat. The average surface temperature is estimated at -170 degrees Celsius, an incredibly low figure. This makes it a frozen super-Earth, whose surface is likely covered with a deep layer of ice, concealing secrets and mysteries beneath. But this doesn't necessarily mean that Barnard's star B is a lifeless and dead world. If geothermal heat exists within its depths, subsurface oceans of liquid water might exist beneath the ice. These oceans could remain liquid for billions of years, which means, in theory, some life forms adapted to extreme conditions could exist there. Some scientists propose that this planet wasn't born in the Barnard star system. It might have once belonged to another star, but as a result of complex gravitational interactions, it was captured by Barnard's star and now orbits this ancient red dwarf. Currently, scientists continue to study this planet to determine if it has an atmosphere and what its internal structure is, which will bring us closer to understanding its nature. Perhaps, in the future, more powerful and sophisticated telescopes will be able to determine if any traces of life are hidden beneath its icy crust, which would be a real discovery for science. Barnard's star is certainly one of the most promising objects for further study and exploration. In about 10,000 years, it will become our closest neighbor, and its planet will be one of the first worlds that humanity can study in detail using advanced technologies. But for now, it remains just a part of the long list of enigmas in the nearby cosmos, awaiting its researchers. Continuing our fascinating journey through the starry sky, our next destination is Lalande 21,185, another red dwarf that may be hiding habitable worlds under its rays, awaiting discovery. Lalande 21,185 is a typical representative of the red dwarf class, but it is also one of the brightest stars of its class in the vicinity of the Sun, which makes it particularly interesting to study. This star is about half the size of our Sun in diameter and half as light in mass, which is a typical indicator for red dwarfs. Like most stars of this class, Lalande is distinguished by incredible longevity and stability. Scientists estimate its age at about 8 billion years, an immense duration. This means it's older than the Sun by at least 3 billion years. Such a substantial age gives its planets an enormous amount of time to evolve, and if life originated somewhere out there in the depths of space, it would have had a much greater chance of developing and flourishing than on our native Earth. However, unlike its turbulent neighbor Proxima Centauri, known for its powerful flares, Lalande is a relatively calm and stable star. It doesn't emit powerful flares capable of destroying planetary atmospheres, nor does it bombard the surrounding space with streams of deadly radiation, making it a much more favorable environment for the formation of stable atmospheres and potentially habitable worlds. That's why scientists around the world are carefully monitoring its planetary system, hoping to find signs of life there. To date, scientists have discovered several planetary candidates orbiting this star, with at least 2 of them potentially being super-Earths, rocky worlds that are larger and more massive than Earth, but smaller than gas giants like Jupiter or Saturn. The most interesting of these planets, named Lalande b, was confirmed by scientists in 2023, a significant event in astronomy. It's approximately twice the size of Earth and orbits its star with an orbital period of 10.5 Earth days. It orbits too close to its star to be habitable in the conventional sense, but if it possesses a dense atmosphere, it could potentially sustain Venus-like conditions, characterized by scorching temperatures and a potent greenhouse effect, rendering it uninhabitable. However, the most intriguing and exciting prospect is Lalande c, a planet candidate that may reside within its star's habitable zone, where liquid water could theoretically exist. If confirmed, it would become one of the most fascinating and promising worlds in our cosmic neighborhood, holding immense scientific interest. Our next stop on this mental odyssey takes us to an even more mysterious and unusual world, shrouded in the impenetrable darkness of space. Thus far, our journey has unfolded among stars that continue to burn, albeit with varying intensities, illuminating the surrounding expanse. However, planets can exist not only around living stars that emit light and heat. They can endure even where their parent star has long since faded and transformed into one of the most extreme and perilous objects in the universe. Such is the case with the PSR B1257 system, the first extrasolar planetary system ever discovered beyond our solar system, a true sensation in the scientific community. Located approximately 2,300 light-years away, this object is a pulsar, the remnant of a supernova explosion that occurred millions of years ago. Once, a star similar to our Sun shone here, but it exhausted its nuclear fuel and collapsed in a cataclysmic explosion, leaving behind only its core, a neutron star spinning at an incredible rate. Now, the PSR-B pulsar emits powerful beams of radiation and magnetic pulses, which can be detected from Earth using modern telescopes. Its rotational speed is astounding, reaching 640 revolutions per second, making it one of the fastest spinning pulsars known in the universe. However, the most astonishing and remarkable discovery was the existence of planets orbiting this deadly object, defying all existing theories. When, in 1992, Polish astronomer Alexander Wolszczan announced the detection of 3 planets orbiting the pulsar, it caused a scientific revolution, sending shockwaves through the field. Before this moment, no one knew for certain whether exoplanets existed around other stars, and even the very possibility seemed doubtful. Various hypotheses and assumptions had been proposed, but there was no concrete evidence. And when these first exoplanetary worlds were finally found, their nature proved to be utterly unexpected and astonishing, contradicting all prior conceptions. How could these planets have survived the supernova explosion, which should have obliterated everything in its path? After all, the supernova explosion should have wiped everything in the surrounding space off the cosmic map, incinerating any existing planetary system and turning it into a cloud of superheated plasma. Scientists believe that two main scenarios could explain this phenomenon. Either these planets were born after the explosion from the remnants of dust and gas left behind after the star's demise, or they existed before the catastrophe but managed to survive it, losing their atmospheres and outer layers, which were torn away by the powerful blast. In either case, this makes them unique and unparalleled. They not only exist, but also continue to orbit one of the most lethal and dangerous objects in the universe, which in itself is an astonishing and incredible fact. Pulsars emit extremely potent X-ray and gamma radiation, capable of destroying any organic molecules that form the basis of life. If Earth were located near such an object, its atmosphere would be destroyed in a matter of days, and the surface would undergo total sterilization, rendering it uninhabitable for any known forms of life. However, the 3 planets discovered around the PSR-B 1257 pulsar somehow managed to exist in this extreme environment, orbiting closely around this compact yet incredibly dense celestial body, seemingly defying the laws of nature. The planet closest to the pulsar has been unofficially named Drauga, a reference to mythological creatures associated with death. It is the lightest known exoplanet in the entire universe, making it a unique object for research. Its mass is only 2/10 of Earth's mass, making it, in essence, even smaller than our Moon. It is possible that this planet is the remnant of a long-destroyed core of a larger world that was annihilated by the pulsar's powerful radiation. It orbits so close to the pulsar that it receives an immense dose of radiation, which should have destroyed all life. Yet its density remains a mystery to scientists, preventing them from understanding its origin. The surface temperature of Drauga reaches approximately 1000 degrees Celsius, making it a scorching and uninhabitable world. But the most terrifying aspect is the incredibly high level of radiation, which makes it even more dangerous. The pulsar continuously bombards this planet with a stream of charged particles and lethal gamma radiation, which could obliterate any known form of life. Further from the pulsar are the planets named Poltergeist and Phobitor, also associated with mystical imagery. Both of these worlds are super-Earths, planets with a mass exceeding that of Earth. Their masses are approximately 4 times the mass of our planet. They are most likely dense, rocky planets, possibly covered with remnants of a dead atmosphere, which was long ago scorched by the powerful radiation emitted by the pulsar. Their orbits around the pulsar are stable, but these planets exist in conditions that make them completely alien and unlike any worlds known to us, presenting an extreme environment. Despite the fact that these planets are most likely dead and devoid of any life, the PSR-B system has forever entered the history of science as the first discovered exoplanetary system, marking a significant milestone in the exploration of space. The discovery of these planets ushered in a new era in astronomy, marking a transition towards a deeper understanding of the universe's structure. It proved that planets are a common phenomenon in the universe, that they can exist even in the most unexpected and extreme locations, and that nature is capable of creating worlds even after catastrophic events such as a supernova explosion. At first glance, these are the most unpromising and uninhabitable worlds ever discovered by humankind. Here, there is no atmosphere, the temperature fluctuates from incredible heat to frigid cold, and the radiation level is so high that it kills all living things, leaving no chance of survival. But if any of these worlds has satellites hidden beneath a thick layer of ice, then life could theoretically be preserved there, protected from the destructive radiation, which is, of course, just a speculation. Until now, our journey has taken us among small and dim stars around which planets orbit, but now it is time to glimpse the world of giants, stars that are hundreds and thousands of times more massive than the Sun and that shape the face of the entire galaxy, exerting a tremendous influence on the surrounding space. These are stars that live fast and burn brightly, consuming their nuclear fuel at an immense rate. and then passing away in dazzling supernova outbursts that briefly become the brightest objects in the universe. If you look at the night sky in the southern latitudes, you can see the constellation Orion, one of the most recognizable and famous constellations in the heavens. Its brightest star, named Rigel, is a sparkling blue giant located approximately 860 light-years away, which is a tremendous distance. Despite this colossal distance, Rigel remains one of the brightest objects in the night sky, astounding in its magnificence. This star, whose size is 1,000 times greater than that of our Sun and whose luminosity far surpasses it, is an example of true cosmic power. But behind this outward grandeur lies a difficult and tragic fate. Rigel is a star that is on the edge of its life, approaching its end. It has already exhausted all the hydrogen necessary to sustain thermonuclear fusion, and now the final stages of synthesizing heavier elements are taking place in its core. This process triggers a chain reaction of demise. As iron accumulates inside the star, it ceases to produce energy, and its gravity causes it to collapse in an instant, leading to a catastrophic explosion. Rigel will inevitably become a supernova, a grand event in the universe. But exactly when this will happen remains unknown. It could happen in 10,000 years, in 100,000 years, or even in 1,000,000 years, which is an immense period for human life. But on the scale of the galaxy, it will happen very soon, like the blink of an eye. When that moment arrives, Rigel will erupt in a colossal explosion, and a new, super-bright star will appear in the sky, capable of temporarily outshining even the moon, becoming the brightest object in the night sky. If such a flare occurred closer to us, it could even affect Earth's biosphere, causing severe climate changes and wiping out many life forms. But the distance of hundreds of light-years makes us relatively safe observers of this cosmic cataclysm. However, Rigel is not a solitary star, but part of a complex system. It is a member of a multiple star system surrounded by 3 satellite stars, which may also undergo catastrophic processes in the future, posing a potential threat to the surrounding space. Its stellar system stands as a true colossus, actively reshaping the surrounding space, generating powerful stellar winds, and significantly influencing the formation of future stars and planets in this region of the galaxy, making it a key element in the stellar system's evolution. However, there are other, even more massive and luminous stellar giants, next to which Rigel seems rather modest and unremarkable. The next destination on our fascinating journey through the cosmos is Betelgeuse, a star that scientists believe is already trembling on the verge of a powerful explosion, heralding its imminent demise. In the depths of space, amidst the bright lights of the Orion constellation, lies one of the most massive and unstable stars known to humankind, astonishing in its size and variability. Betelgeuse, this red supergiant, burns with a dying flame, like a candle burning out in the night, teetering on the brink of an explosion that could happen at any moment, transforming it into a dazzling supernova. Perhaps, even as you listen to these words, it has already erupted, and the light of its catastrophic demise is racing towards us through hundreds of light-years, ready to astound our imagination. Betelgeuse is located approximately 640 light-years from Earth, and even from such a vast distance, it remains one of the brightest and most noticeable stars in the night sky, attracting the gaze of observers. This is a star that is 1,000 times the size of our Sun, and its luminosity far surpasses it, making it one of the most powerful luminaries in our galaxy. But behind this external grandeur and beauty lies a difficult and tragic fate, predetermined by the laws of physics. Betelgeuse is a star in the very last stage of its life, like an old warrior preparing for his final battle. It has already exhausted its supply of hydrogen, needed to sustain thermonuclear burning in its depths, and now its core is undergoing the final stages of synthesizing heavier elements such as helium, carbon, and oxygen. The process of converting heavy elements into even more massive ones is in full swing, bringing the star closer to its inevitable end. Its core is already saturating with iron, which means that the moment of catastrophic collapse is approaching, marking the beginning of its demise. When there is too much iron, the star will lose its ability to resist its own gravity, which will begin to compress it with immense force. This will be a moment of catastrophic collapse, when the entire mass of the star will implode inward in a fraction of a second, compressing to incredible density and triggering a powerful supernova explosion that will shake the entire galaxy. We know that this star is already behaving extremely unstably, as if sensing its doom. In 2019, astronomers recorded an unusual and mysterious dimming of Betelgeuse, which caused a wave of speculation and conjecture in the scientific community. Had the final stage of its evolution already begun, heralding an imminent explosion? But then the star's brightness recovered, and it became clear that it was just a giant ejection of matter from the star's depths, temporarily obscuring it from our eyes, creating the illusion of dimming. However, such powerful ejections of matter are a clear indication that the star is undergoing the last convulsions before its inevitable explosion, like an agonizing beast. When it finally happens, Betelgeuse will become the brightest supernova humanity has ever witnessed in its entire history, surpassing all previously known events in brightness. The flash will be so powerful that a new star will appear in the sky, shining brighter than the full moon, eclipsing all other objects. It will be visible even during the day, which is an incredible phenomenon. And at night it will cast shadows on the surface of the Earth, creating a mystical atmosphere. This spectacular sight will last for several weeks or even months, until the scattered outer layers of the star dissipate into space, gradually fading away. Despite the colossal energy that will be released as a result of this explosion, we, the inhabitants of Earth, are in virtually no danger. Betelgeuse is far enough away from us that neither the shockwave nor the radiation emitted during the explosion will reach Earth in dangerous quantities, harming living organisms. But the event itself will be of paramount importance to science, providing a unique opportunity to study the processes that occur during the death of stars. We will be able to observe the process of a star's death firsthand, understand what elements are ejected into space as a result of this explosion, and possibly see the formation of a new neutron star or even a black hole, which will allow us to approach an understanding of the fundamental laws of the universe. After the explosion of Betelgeuse, the core of the former star will remain at its very center, the last refuge of its energy. If its mass turns out to be less than 3 solar masses, then it will turn into a neutron star, which is an incredibly dense object in which atoms are literally compressed by gravity to the limit, and a teaspoon of the substance that it is made of will weigh billions of tons, which is mind-boggling. If the core is more massive, then its collapse will not stop at the formation of a neutron star, and it will continue to compress until it turns into a black hole, which is a region of space from which even light cannot escape, forever disappearing into its depths. But the demise of Betelgeuse will not be the end of everything, but rather the beginning of a new cycle in the evolution of the universe, as if the death of one generation gives life to a new one. The elements scattered in the explosion will replenish the reserves of interstellar gas, from which new stars and planets will eventually form, continuing the cycle of life in the universe. It is such supernova explosions that enrich the universe with heavy elements, which are necessary for the formation of planets and the existence of living organisms, making the emergence of life possible. Particles ejected during the explosion, millions of years later, may become part of new worlds, new suns, and perhaps even new life, which is one of the most amazing and mysterious processes in the cosmos. Deep in the heart of the Milky Way, hidden behind dense clouds of gas and dust, like a jewel, blazes one of the brightest and most massive stars in our galaxy. astonishing in its size and luminosity. This star is known as the pistol star, which reflects its power and energy. It emits energy 10 million times greater than the luminosity of our Sun, making it one of the most powerful sources of energy in the entire known universe, astonishing in its scale. The pistol star is located approximately 25,000 light-years away in the direction of the center of our galaxy, the Milky Way, which is a vast distance. Its glow is so intense and powerful that even from such a colossal distance it could be seen with the naked eye, if not for the dense veil of interstellar dust and gas obscuring it from our view like a mysterious shroud. For millions of years, this star has been emitting colossal streams of radiation and stellar wind, ejecting huge clouds of matter into the surrounding space like a giant fountain gushing from the depths of the cosmos. The pistol star belongs to the class of blue hypergiants, which are rare and unique objects, possessing extreme mass and incredibly high surface temperatures, making them some of the hottest and brightest stars in the universe. Its mass is approximately 90 times greater than the mass of our Sun, and the temperature on its surface reaches 30,000 degrees Celsius, which is an incredibly high figure. But the most important and impressive thing about this star is its light output, exceeding all reasonable limits. In 1 second, it emits as much energy as our Sun emits in several years, making it one of the most significant and influential stellar objects in our galaxy, exerting a huge impact on the evolution of the surrounding space. However, such incredible power and brightness come at a price, and the price for this is a short life. The pistol star burns its nuclear fuel at a terrifying rate, which means that its life will be very short by cosmic standards. While our Sun, a medium-sized star, will be able to exist for 10 billion years, the pistol star will live no more than a few million years, which is a blink of an eye on the scale of the universe, and it is currently in the very last stage of its life, approaching its tragic end. During its short but turbulent life, this star has already ejected a huge amount of matter into the surrounding space, creating around itself a giant and beautiful nebula, like a kind of monument to itself. These ejections of matter indicate that the last processes are already underway in the star's depths before the inevitable collapse, heralding an imminent supernova explosion that will shake the entire galaxy. This means that the explosion, predetermined by the laws of physics, is inevitable. When all of its nuclear fuel is finally exhausted, the process of gravitational collapse will begin in the center of the star, compressing it to incredible density. The internal pressure will no longer be able to hold back the outer layers of the star, and they will be ejected into the surrounding space in a colossal supernova explosion, which will become one of the brightest events in the universe. But this will not be just an ordinary supernova, but something much more powerful and destructive. Given its immense mass and energy, the pistol star could become a source of a gamma-ray burst, one of the most powerful and mysterious phenomena in the universe, the nature of which remains a subject of debate among scientists. A gamma-ray burst is a short but incredibly intense burst of gamma radiation, which can spread over thousands of light-years, incinerating everything in its path and posing a huge threat to all living things. This is such a destructive and powerful event that if it occurred within a few thousand light-years of Earth and was directed towards us, it could destroy a significant portion of our planet's atmosphere, causing mass extinction of species and irreversible changes in the environment. Fortunately for us, however, the pistol star is too far from Earth, and even if it does generate a gamma-ray burst, it will not harm our planet, remaining merely a grandiose cosmic spectacle that we can observe from a safe distance. But we will be able to witness it as one of the most magnificent and breathtaking cosmic events in human history, marveling at its scale and power. In the depths of space, there are numerous stars whose fate is already predetermined and unavoidable, as if written in the stars. They do not simply burn out and disappear into the cosmic void, but fall into the clutches of gravitational monsters from which there is no escape, becoming victims of their insatiable hunger. One such ominous system is V404 Cygni, located approximately 8,000 light-years away from us in the constellation Cygnus, which is a vast distance. Here, in eternal darkness, unfolds a silent and tragic struggle between a dying star and an insatiable black hole, which slowly but inevitably devours its stellar companion, condemning it to eternal oblivion. It is a system in which one object irretrievably loses matter, becoming a victim of a gravitational monster, while the other steadily grows and gains mass through this process, increasing its power. The black hole, invisible and mysterious in itself, manifests its presence and influence in a different way. Its presence is betrayed by streams of incandescent gas that stretch from its victim like tentacles and form a huge rotating accretion disk surrounding the black hole. This substance, torn from the surface of the star, accelerates to incredible speeds, heats up to millions of degrees, and begins to emit powerful bursts of X-rays that flash into space like signals of destruction and doom, warning of danger. The companion star, the victim of the black hole, is a red giant, a massive but already aging star whose best days are behind it. Its outer envelope is becoming increasingly weak and vulnerable to the gravitational influence of its neighbor, which is gradually tearing streams of gas from its surface, swirling them into a blazing vortex heading towards the black hole. This tragic process has been going on for thousands of years, and its outcome is inevitable and predetermined. At some point, the star's orbit will narrow to such an extent that it will no longer be able to resist the gravitational pull of the black hole, and its fall will become unavoidable. Then its core will be too close to the black hole, and all the remaining matter of the star, in a final burst of energy, will collapse beyond the event horizon, disappearing forever and becoming part of the hidden monster that will continue its existence in eternal darkness. But before finally disappearing, it will stage a spectacular final act, representing a powerful burst of energy that can tear apart the entire system and release colossal streams of matter into open space, like a farewell salute. These ejections, called relativistic jets, occur when some of the matter swirling in the accretion disk fails to fall into the black hole and is ejected outwards with tremendous force at near light speed, forming narrow beams of plasma. At such moments, the V404 Cygni system becomes one of the most powerful sources of X-ray radiation in the entire galaxy, like a beacon signaling destruction. After the tragic demise of the star, the black hole will become only slightly more massive, having devoured the remains of its stellar companion. Its gravitational field will be a little stronger, but it will remain just as silent and invisible, immersed in endless darkness and continuing its existence in solitude. The once hot and bright accretion disk that surrounded the black hole will gradually begin to cool and dim, and the powerful X-ray flares that were its hallmark will disappear forever. The gravitational duo, which had existed for millions of years, will finally come to an end, leaving behind only silence and darkness. Until now, our fascinating journey has been primarily dedicated to the study of stars, those giant luminaries whose fate is inevitably linked to catastrophe and destruction. However, life, if it exists beyond Earth, depends not on the stars themselves, but on the worlds that orbit them and receive light and heat from them. It is planets that are potential cradles of life, and the search for such places in the universe remains one of the main tasks of modern astronomy, striving to find the answer to the question of whether we are alone in the universe. One of the first star systems where planets, possibly similar to our Earth, were discovered was Gliese 581, located only 20 light-years away from us in the constellation Libra, which is a very short distance by galactic standards. And if humanity had a spaceship capable of accelerating to 10% of the speed of light, we could reach this star system in just 200 years, which is a perfectly realistic time frame. But even without actual flights to these distant worlds, we already know enough about them to assert that there may be conditions there that are potentially suitable for the emergence and sustenance of life, making this system particularly interesting for researchers. Gliese 581 is a red dwarf representing a small and dim star whose luminosity is only 0.5% of the luminosity of our Sun, making it much less bright and hot. In recent years, astronomers have discovered several planets around this star, but two of them particularly stand out from the rest and attract the most attention. The first of these planets, Gliese 581d, became the first super-Earth found in the potentially habitable zone of its star, which was an important discovery. In terms of mass, this planet is approximately 7 times larger than Earth, and its orbit passes on the outermost edge of the habitable zone of its star, making it a possible candidate for an oceanic world covered in water. If this planet has a dense atmosphere similar in composition to Earth's, it could retain heat through the greenhouse effect, and its surface could be covered in deep oceans of liquid water, creating conditions conducive to the existence of life. However, a world with such a huge mass would be significantly different from Earth. On the surface of Gliese 581d, gravity would be approximately twice as strong as on Earth, which would make any movement difficult and tiring for a human. If life existed on this planet, it would probably take completely different forms, adapted to higher gravity and possible high atmospheric pressure, making it unique and unlike the worlds we know. Even more mysterious and intriguing is the planet Gliese 581g, the existence of which is still in question. The discovery of this planet was announced back in 2010, but its existence has not yet been definitively confirmed and remains a subject of debate among scientists. If this planet does exist, it is one of the best candidates for a habitable exoplanet, as its orbit passes exactly in the very center of the habitable zone of its star, where theoretically the most favorable conditions for the emergence of life are possible. But even if this planet does exist, it has one feature that could greatly affect its climate and surface conditions. Since Gliese 581 is a red dwarf, its planets are very close to the star, which means that they are almost certainly tidally locked, meaning that one side of the planet is always facing the star, while the other is constantly in eternal shadow. If we somehow found ourselves on the planet Gliese 581d, we would most likely see a dense and opaque atmosphere, possibly similar to Venusian, but with a less extreme and harsh climate. Due to the high gravity, the oceans could be much deeper than on Earth, and the atmosphere more dense, creating constant cloud cover and severe storms raging over the planet's surface. On the planet Gliese 581g, if it does exist, the climate would probably be quite different and more contrasting. Due to tidal locking, one side of the planet is constantly bathed in light and is possibly a scorching desert where temperatures reach high values, while the other side is constantly in eternal shadow and covered with a thick layer of ice where eternal cold reigns. However, between these two extreme zones, there is a narrow twilight strip where a more comfortable temperature suitable for the existence of life may be maintained. It is in this small region that oceans or rivers of liquid water and even conditions favorable for the emergence and sustenance of life could exist. Today, thanks to new and improved research methods, scientists around the world continue to actively study the Gliese 581 star system, striving to unravel all its mysteries. In the future, when next-generation telescopes with unprecedented power and accuracy will be able to analyze the chemical composition of exoplanet atmospheres, this system will become one of the highest priority targets for the search for oxygen, methane, and other possible biomarkers that may indicate the presence of life. This star system vividly reminds us that Earth may not be a unique and the only habitable world in the universe, and that within only a few dozen light-years from us, there may be other worlds where it rains, oceans roar, and winds blow, creating amazing and diverse landscapes. There are other planets that are even more similar to Earth in their characteristics, and one of them is Kepler 442b, representing another world that may become our second home, or even a new home for all of humanity in the future. Located 1,100 light-years from Earth in the constellation Lyra, this world has become one of the most interesting and promising objects to study, attracting the attention of scientists around the world. Its orbit passes around a yellow dwarf, very similar to our Sun in size and temperature, which makes the conditions on the planet potentially favorable for maintaining liquid water on the surface and a stable climate necessary for the emergence of life. This world is a super-Earth, belonging to a class of planets that are significantly more massive than our home planet. Its mass is about twice that of Earth, and its radius is about 30% larger, making it bigger and denser. This results in the gravity on the planet's surface being slightly stronger than on Earth, but not so much that it would pose a serious problem for hypothetical life. A person who landed on this planet could move around without much difficulty, although they might need to develop their muscles a bit more to adapt to the increased gravity, which is quite possible over time. What makes Kepler 442b particularly interesting and promising for life is its position relative to its host star within the habitable zone. It receives about 70% of the radiation that Earth receives from the Sun, which makes the climate on its surface potentially temperate and comfortable for life. If the planet has a dense atmosphere containing greenhouse gases, such as carbon dioxide and water vapor, it could effectively retain heat, creating Earth-like conditions and maintaining a temperature at the level necessary for the existence of liquid water. The probability of liquid water existing on the surface of Kepler 442b is estimated by scientists at about 60%, which is quite high. And while these are just assumptions, they are quite sufficient to consider this world as one of the best candidates for habitability and the possibility of life. If it were somehow possible to set foot on the surface of Kepler 442b, the environment might seem surprisingly similar to Earth, but with some differences, such as denser air and perhaps more massive mountains formed due to increased gravity. The sky would look a little dimmer than ours, since the star around which the planet revolves emits a little less light. But otherwise, this world could be surprisingly familiar and similar to our home, which makes it even more attractive. If there were oceans on this planet, their waves would be much more powerful, and the air currents would be denser, creating a completely different atmospheric dynamic than on Earth. However, the real conditions existing on the surface of Kepler 442b are, unfortunately, still unknown, and this remains a mystery to scientists. The planet is too far away from us, and even the most powerful telescopes currently in existence do not allow us to determine the chemical composition of its atmosphere, which is a key factor in determining its habitability. Perhaps in the future, when humankind has at its disposal a new generation of space observatories with much greater sensitivity and resolving power, we will be able to find out if there is oxygen, water vapor, or other chemical markers indicating the potential existence of life, which would be a real breakthrough in the study of exoplanets. But while this world remains beyond our immediate study, there are other planetary systems much closer to us, where perhaps even more amazing and exciting discoveries are hidden, waiting for their time. In one such place, located only 40 light-years away, is the TRAPPIST-1 star system, which is a miniature copy of the solar system, but with a completely different and more compact structure. As many as 7 planets revolve around its faint red dwarf, and they are all comparable in size to our Earth, which makes this system unique and unlike other planetary systems known to us. This amazing system is located 40 light-years away in the constellation Aquarius, which is a relatively short distance by cosmic standards. The planets of this system were first discovered in 2015, and subsequent observations made with the Spitzer Space Telescope confirmed the existence of an entire system of Earth-like worlds, several of which are located in the so-called habitable zone of their star. The central star of the TRAPPIST-1 system is an ultra-cool red dwarf, which is much smaller and dimmer than our Sun, representing a completely different type of star. Its mass is only 8% of the mass of our Sun, and its diameter barely exceeds the size of Jupiter, the largest planet in our solar system, making it incredibly small. This is one of the smallest and coolest known red dwarfs, which defines the unique conditions in its planetary system. And its light is not the bright white light that we are used to on Earth, but a faint red glow, creating a completely different atmosphere, which must be taken into account when assessing the possibility of life on the planets of this system. But despite its faint brightness and small size, this red dwarf has an incredibly dense and compact system of planets, which makes it unique and unlike other star systems. All 7 planets of the TRAPPIST-1 system are located very close to the star, revolving around it with short orbital periods. But due to its relatively low temperature, several of them still receive enough heat and energy for liquid water to exist on their surfaces, which is a prerequisite for the emergence of life. All the planets in this system are tidally locked, which means that they always face their star with the same side, which has a significant impact on their climate and surface conditions. Among the 7 worlds of the TRAPPIST-1 system, scientists are particularly interested in the planet TRAPPIST-1e, located in the very middle of the habitable zone of its star, which makes it the most promising for the existence of life. The density of this planet indicates that it is likely to have a solid surface, consisting of rocks, rather than being a gas giant. Scientists believe that this planet may have an atmosphere that protects its surface from harmful cosmic radiation and maintains a stable temperature. And if that's indeed the case, then in its climate zone, located in the twilight zone between the constantly illuminated and constantly shadowed sides, there may be rivers, oceans and clouds, supporting water circulation and creating conditions conducive to the development of life. But other planets in this unique system do not rule out the possibility of liquid water existing on their surfaces, making the TRAPPIST-1 system one of the most interesting objects for further research. Some of these planets may be ocean worlds, completely covered with a thick layer of ice, beneath which hidden subsurface oceans of liquid water, similar to those that exist on the moons of Jupiter and Saturn. The TRAPPIST-1 star system has already become one of the main targets for new space telescopes, including the powerful James Webb Telescope, which allows us to see what was previously inaccessible to observation. A unique feature of the planets in this system is that they pass in front of their star with high frequency, which gives scientists the opportunity to study the composition of their atmospheres using the spectroscopy method, analyzing how the star's light passes through the planet's atmosphere. All of the above planets are just some of the many candidates for extraterrestrial life found by scientists in recent years. Among the various exoplanets discovered in recent decades, there is one that has forever entered the history of astronomy as the first to have its atmosphere found to be evaporating. HD 209,458b is not just another gas giant orbiting a distant star, but a world that has become one of the first objects in which scientists have observed the evaporation of the atmosphere under the influence of powerful stellar radiation. This planet is located approximately 155 light-years from Earth in the constellation Pegasus, which is a relatively short distance by cosmic standards. It was discovered in 1999, becoming one of the first exoplanets discovered using the transit method, which is based on measuring a small decrease in the brightness of a star when a planet passes in front of it. This world is a gas giant, but it cannot be compared to Jupiter, as it has a number of unique characteristics. Despite its similar mass, it is on a very close orbit to its star, revolving around it in just 3.5 days, which is an incredibly short orbital period. Because of this, HD 209,458b belongs to the class of hot Jupiters, planets that are so close to their star that their atmospheres begin to heat up, expand, and gradually evaporate into space. The temperature on the surface of this planet reaches 1,000 degrees Celsius, which makes its atmosphere extremely unstable and prone to destruction. Under the influence of stellar wind and powerful ultraviolet radiation, the atmosphere of HD 209,458b gradually evaporates, creating a giant plume of gas that goes into outer space and resembles a comet tail. This process is in some way similar to what happened to Mars in the distant past, when it lost most of its atmosphere under the influence of the solar wind, which led to its transformation into a cold desert. But in the case of this exoplanet, this process is happening much faster and on a larger scale than on Mars. This gas giant is in the process of slow disappearance, gradually losing its substance. Every year, it loses huge amounts of matter, which is carried away by the stellar wind into the surrounding space. Perhaps, in the distant future, in millions or billions of years, this planet will completely lose its outer layers, turning into a naked planetary core devoid of any atmosphere. When we look at the night sky, only a small and insignificant part of that colossal and immense star system in which we exist unfolds before our eyes. Ancient civilizations saw in this luminous band in the sky, called the Milky Way, a mystical road, the scattered dust of gods, or a trace left on the path of the soul's movement, populating the cosmos with gods and spirits. But now, thanks to scientific discoveries, we know that this faint glow is none other than our own galaxy, a vast world composed of stars, gas, dust, and the invisible forces of gravity that govern its motion, holding it together as a single entity. The Milky Way galaxy is so immense that even light, traveling at its incredible speed, would require 100,000 years to traverse it from one end to the other, a truly astronomical figure. Within this gigantic and unfathomable expanse lie hundreds of billions of stars, many of which possess their own planets orbiting them, and among these planets there may well be worlds remarkably similar to our own, waiting to be discovered. And yet, despite its colossal size and complexity, our Milky Way galaxy remains but one of hundreds of billions of other galaxies scattered across the boundless expanse of space, like grains of sand on an endless beach. If we were granted the unique opportunity to view our galaxy from afar, we would behold a graceful spiral structure, elegantly extending its long and curving arms around a bright central nucleus, captivating the imagination with its beauty and grandeur. These spiral arms, appearing motionless and frozen in time, are in reality density waves, resembling those that ripple across the surface of water when a stone is cast into it, spreading in all directions. Stars, gas, and dust continuously move through these density waves, compressing in certain areas and giving birth to new stars, like cosmic maternity wards, where new luminaries are born, illuminating the galaxy. At the very heart of the galaxy lies a dense and brightly luminous region known as the bulge, representing the galactic nucleus. This nucleus consists primarily of ancient stars, formed at the very dawn of the galaxy's existence when it was still in its infancy. These old stars move in chaotic and unpredictable orbits, constantly intertwining with one another as if in an intricate dance, while the space between them is filled with hot gas, dusty clouds, and powerful magnetic fields, creating incredible conditions. It is here, in the very heart of the galaxy, that one of the Milky Way's greatest mysteries lies hidden, a supermassive black hole whose gravitational influence is felt across thousands of light years, exerting a significant impact on all the surrounding space. Surrounding the galactic nucleus stretches a vast stellar disk, representing the region where young stars, gas clouds, and planetary systems are found, including our own solar system in which we dwell. Within this disk, stars orbit the galactic center, much like planets orbit the sun. But one complete revolution around the galactic center takes hundreds of millions of years, an immense span of time. Our Sun, for example, travels in its orbit at a speed of 220 kilometers per second and completes one full circle around the galactic center in approximately 225 million years, equivalent to one galactic year. The last time the Sun was in the same position in its orbit, dinosaurs still roamed the Earth, a testament to the scale of time within the galaxy. But the Milky Way galaxy is not just stars, gas, and dust. A vast and virtually invisible region surrounding the galaxy is called the galactic halo, a sort of cocoon enveloping the galaxy. It is a sphere composed of ancient globular clusters, scattered stars, and the enigmatic dark matter, whose nature remains one of the greatest mysteries of modern science. We cannot directly observe dark matter, as it does not interact with light, but we know it exists because of its gravitational influence on surrounding objects. It is what prevents the galaxy from disintegrating, creating an invisible gravitational network that binds all its parts together and ensures its stability. Without dark matter, the galaxy's spiral arms would have long since stretched and deformed, and the stars would have begun to scatter in different directions, leading to its destruction. At first glance, it may seem that this entire vast and complex structure is immutable and static, but this is far from the case, and the galaxy is in constant motion and change. The Milky Way galaxy is constantly moving through space, changing its shape, absorbing small dwarf galaxies, leaving their stars in its halo, colliding with streams of intergalactic gas and ejecting powerful jets of energy from its center, demonstrating its activity. It does not stand still, even on the scale of the entire universe, constantly interacting with other galaxies. Together with neighboring galaxies, our galaxy is moving towards the Virgo cluster, a massive gravitational well that attracts hundreds and thousands of galaxies, including our own. And yet, despite all the data collected and numerous studies, our Milky Way galaxy remains largely a mystery and harbors many unsolved secrets. We cannot see it in its entirety from the outside, since we are located inside it, and even the most powerful modern telescopes can only construct hypotheses and guesses about its full shape and structure based on indirect data. The Milky Way is a complex and organized structure in which each part performs its specific role and contributes to its overall functioning. The galaxy is a complex and organized structure in which each part performs its important role and contributes to its functioning and evolution. We already know that our galaxy has a spiral shape, and its disk is crossed by huge density waves filled with young stars, gas, and dust, creating impressive scenes. The spiral arms are a kind of moving galactic river, along which stars, clouds of gas, and nebulae continuously flow, shaping its structure. They form the basic pattern of the Milky Way, creating its majestic and recognizable appearance, which we can observe in the night sky. If we had the opportunity to look at our galaxy from the outside, we would see several main spiral arms diverging from the central bulge, like rays of sunlight emanating from its core. Inside these spiral arms are the youngest and brightest stars, as these arms are the main zones of active star formation, where gas is compressed and new luminaries are born. However, stars are not permanently attached to these arms, and they can move through the galaxy, changing their position relative to the arms. They move within the galaxy, periodically entering and exiting the arms, like cars entering and exiting a highway, creating a dynamic picture. Our solar system, in which we live, is located in a small spur between two main spiral arms, known as the Orion Arm, a relatively quiet place in the galaxy. This modest but incredibly important section of the Milky Way is where not only our Sun and the stars closest to us are located, forming our stellar neighborhood, but also such well-known and beautiful objects as the Orion Nebula, the Pleiades, and Alpha Centauri, attracting the attention of astronomers around the world. The Orion Arm is not the densest and most populated part of the galaxy, and this may have been very fortunate for us and for the emergence of life on Earth. If our solar system were located in one of the main and largest spiral arms of the galaxy, the surrounding space would be much more saturated with stars, presenting a potential danger. And this, in turn, would mean that the Earth would be much more frequently exposed to supernova outbursts, powerful stellar winds, and other catastrophic and destructive phenomena that could hinder the development of life. Perhaps it is the relatively quiet and remote location of our solar system that has allowed our planet to develop for billions of years, without being subjected to serious cosmic catastrophes and maintaining stable conditions for the development and evolution of life. The Milky Way has several main spiral arms that form its global structure and define its appearance, differing in size and characteristics. The Perseus arm is one of the most massive and extended arms, passing through the outer disk of the galaxy and characterized by a high density of stars. It contains a huge number of young stars, hot blue giants, and vast regions of active star formation where new luminaries are born. If we had the opportunity to see the Milky Way from above, this arm would look like one of the brightest and most impressive branches of the galaxy, glittering in cosmic space. The Sagittarius arm is located closer to the center of our galaxy and is one of the most active star-forming zones, where stars are born by the thousands. It is here that you can find some of the most massive and brightest stars in the Milky Way, including huge clusters of blue supergiants and impressive nebulae, such as the Lagoon Nebula and the Eagle Nebula, striking in their beauty. The Cygnus arm passes along the outer edge of the galactic disk and is filled with stars of later generations, representing an older structure. It contains dense molecular clouds consisting of hydrogen and other elements from which new stars continue to form, as well as many diverse nebulae and open star clusters, creating a colorful cosmic landscape. The Scutum arm is one of the brightest and most saturated arms of our galaxy, containing dense star clusters and active regions of new star birth. It is one of the main regions of the Milky Way, where you can observe the youngest stars, surrounded by the gas clouds from which they have just formed, presenting a breathtaking sight. While it might seem that spiral arms are made up of the same stars all the time, this isn't quite the case, and they are in fact dynamic structures. They are density waves that compress the gas passing through them, creating conditions conducive to star formation. When hydrogen clouds enter a spiral arm region, they begin to condense under the force of gravity, and star formation processes are triggered within them, leading to the birth of new stars. Thus, spiral arms are moving streams where new stars are constantly being born, like cosmic assembly lines. The Sun may once have been created in one of these arms, and then, millions of years later, moved out of it and into a quieter, more peaceful part of the galaxy, where it is now located. This process occurs constantly and continuously. Stars are born, move through the galaxy, leave the arms, and move to other regions, while the arms remain eternal cradles for the birth of new stars. A small star system, a dwarf galaxy in Sagittarius, one of our galaxy's closest satellite galaxies orbiting around us, is moving around the Milky Way. Its orbit passes very close to the galactic disk, and for billions of years it has been gravitationally disrupted by the tidal forces of our galaxy. Each time it passes by the Milky Way, its stars are stretched by gravity and begin to scatter into different orbits, forming a stellar stream that now encircles our galaxy like a torn ring. This process of destruction doesn't stop and continues to this day, slowly but surely destroying the dwarf galaxy. The satellite continues to lose stars, and eventually it will disappear completely, dissolving into our galaxy and becoming just part of the Milky Way's halo, replenishing its composition. The process of merging galaxies is not something rare and unusual, but rather the main way in which large galaxies grow in the universe, playing an important role in their evolution. We are used to thinking that galaxies exist in isolation and are isolated from each other, But in reality, they are constantly interacting with surrounding structures, attracting and absorbing each other like cosmic predators. Scattered throughout the Milky Way's halo are traces of many other absorbed star systems, each of which was once a separate galaxy or compact cluster of stars, but was absorbed by our galaxy. Some of these streams are remnants of dwarf galaxies that have been torn apart by the gravity of our galaxy, while others are destroyed star clusters that have lost their gravitational bound and are now stellar filaments stretching for thousands of light-years in cosmic space. One of the most famous examples of such absorption is the Helmy Stream, a relatively recently discovered structure consisting of the stellar remnants of one of the most ancient galaxies that collided with our Milky Way galaxy in the distant past. These stars move in unusual and elongated orbits, different from the orbits of stars formed in our galaxy, and carry valuable information about the history and early stages of the formation of our stellar home. There is also a giant stream, an extended structure formed as a result of a collision between our galaxy and another dwarf galaxy, which occurred more than 10 billion years ago, at the very beginning of its existence. These stars have already mixed so much with the stars of the Milky Way's halo that they have become an integral part of it, and it is difficult to distinguish them from those that formed in our galaxy. The gravitational effects of these collisions can change the shape of our galaxy, influencing the location of its spiral arms, causing new waves of star formation, and even leading to shifts in the orbits of stars in the galactic disk, significantly affecting its evolution. Galaxy mergers can also lead to accelerated growth of the supermassive black hole located at the center of our galaxy, which begins to absorb more matter. Some scientific models suggest that it is these collisions that fuel the core of the galaxy, increasing the activity of the central region and leading to more powerful energy emissions. All of this convincingly demonstrates that our Milky Way galaxy is not a static and unchanging object, but a dynamic and ever-changing system in continuous development. It is constantly evolving, absorbing new stars and entire galaxies, changing its internal structure, and perhaps already contains the remnants of dozens of absorbed galaxies, traces of which we are only beginning to find, making it even more mysterious. Our fascinating journey through the Milky Way galaxy has already clearly demonstrated that the galaxy is a complex and dynamic system, constantly changing under the influence of gravity and interacting forces. We have seen how it grows and evolves, absorbing other stars and galaxies, how its spiral arms guide the movement of gas and form new stars, and how dark matter influences its structure. However, behind all these processes lies another force, invisible and mysterious, but vital for the existence of the galaxy. It determines the movement of stars, holds the galaxy together as a whole, and prevents it from disintegrating under the influence of gravity. This is dark matter, a mysterious component without which the Milky Way galaxy simply could not exist in its current form and would have long since disintegrated. Back in the first half of the 20th century, astronomers began to notice the unusual behavior of stars located in the outer regions of galaxies, which did not correspond to existing theories. If the only force holding them in orbit around the center of the galaxy was the gravity of the observed matter, then distant stars, located at a greater distance, would move more slowly than nearby stars, which is a natural consequence of the laws of physics. This is quite natural. The further an object is from the center, the weaker the gravity acting on it, and the slower it must move to remain in its orbit. However, observations showed the exact opposite. Stars located at the edges of galaxies rotate around the center at almost the same speed as stars closer to the center, which contradicted all existing ideas. This mysterious effect, called the anomaly of galactic rotation curves, became one of the first and most convincing pieces of evidence for the existence of an unknown form of matter that is invisible to our telescopes. If this invisible matter did not exist, then gravity simply could not hold the stars at such high speeds, and they would leave the galaxy and scatter into cosmic space, which, however, does not happen. But this does not happen in reality. This means that there is some invisible mass in the space around us that creates an additional gravitational field, holding the stars in their orbits and preventing them from leaving the galaxy. According to modern scientific understanding, up to 80% of the mass of a galaxy is dark matter, making it the predominant component of the galaxy. It does not glow, does not interact with ordinary matter through electromagnetic forces, and does not absorb light, making it invisible to our instruments. We cannot see dark matter directly, but we can observe its gravitational influence on surrounding objects, which allows us to indirectly judge its existence and properties. Scientists do not yet know exactly what dark matter is, and this question remains one of the most difficult in modern physics and astronomy. It may be an unknown type of elementary particle that interacts very weakly with the surrounding world, or even a fundamental feature of gravity itself that we do not yet fully understand, which is why scientists are developing various hypotheses. But one thing is certain. Without dark matter, the Milky Way galaxy would look completely different and could not exist in its current form. This mysterious substance plays the role of an invisible framework on which the entire structure of the galaxy is built, determining its shape and stability. It affects not only the movement of stars, but also the formation of large-scale cosmic structures, preventing them from collapsing. For example, the spiral arms of the galaxy would eventually blur and lose their shape, but dark matter helps them maintain their structure and support active star formation, which is crucial to their evolution. However, in addition to dark matter, which has a global impact on the galaxy, there is another force in our galaxy that plays a key role in its fate and has a significant impact on the surrounding space. This is its central supermassive black hole, an object whose gravitational influence is felt for thousands of light years. There, in the densest and most luminous core of our Milky Way galaxy, lies Sagittarius A, a supermassive black hole with a mass more than 4 million times that of our Sun, which boggles the mind. This gravitational monster is a central element of our galaxy's architecture, having a colossal impact on the movement of stars in its core and playing a key role in the formation and evolution of the galaxy over billions of years. Although the very existence of black holes was predicted within the framework of the general theory of relativity developed by Albert Einstein, proving their reality and seeing them with our own eyes turned out to be an incredibly difficult task, requiring enormous effort and advanced technologies. Sagittarius A was first discovered in the 70s of the last century as a powerful and mysterious radio signal emanating from the very center of our galaxy, which caused great interest among scientists. But it was only at the end of the 20th century that astronomers were able to realize that this source has incredible gravitational power, capable of controlling the movement of stars in the galactic core, forcing them to move along complex trajectories. The most convincing evidence for the existence of Sagittarius A was obtained when scientists began to carefully track the movement of individual stars located near the center of the galaxy. For 2 decades, astronomers meticulously observed these stars as they traced intricate circular orbits around an unseen object, accelerating to incredible speeds approaching that of light. One of these stars, designated S2, has garnered particular attention. It hurtles around the galactic center at a staggering 15 million kilometers per hour, a truly astonishing figure, completing a full orbit around Sagittarius A in just 16 years. This unusual stellar behavior could only be explained by one thing: a colossal mass lurking at the galaxy's heart, yet utterly invisible, leaving scientists baffled. This enigmatic unseen entity was ultimately identified as a supermassive black hole, a pivotal discovery in astronomy, and it was not until 2022 that humanity managed to glimpse its shadow, the first direct evidence of its existence. Utilizing a global network of radio telescopes, united in an international endeavor known as the Event Horizon Telescope, scientists captured the first ever image of the event horizon of the black hole Sagittarius A, a monumental breakthrough. This historic image revealed a bright and distinct ring of superheated gas swirling around the black hole at tremendous velocity, encircling a dark central region from which not even light can escape, corroborating the predictions of the theory of relativity. A black hole represents a distortion of space and time caused by an immense mass compressed into the smallest possible volume, creating extraordinary gravitational forces. In the case of Sagittarius A, we are dealing with a mass exceeding that of the Sun by 4 million times, packed into a region smaller than the distance between the Sun and Mercury, an incredibly dense concentration. This means the density of matter in this region is so extreme that the gravity nearby becomes unbelievable, bending light, distorting the paths of moving objects, and stretching time, creating unique effects. One of the most astounding and mysterious features of any black hole is the event horizon, an invisible boundary beyond which nothing, not even light, can escape back, making it a peculiar trap. It is the event horizon that separates the region accessible to external observation from the region where information about the processes taking place is lost to the outside world and becomes inaccessible for study. If an object approaches a black hole, it begins to experience an increasingly strong and uneven gravitational stretching, which intensifies as it nears the event horizon. This effect, known as spaghettification, is particularly noticeable if the object has an extended shape and consists of different parts. For example, if an astronaut carelessly fell into a black hole, their feet would experience a much stronger gravitational pull than their head because they are closer to the black hole. This would cause their body to be stretched into a thin, long line like a strand of spaghetti before they ultimately disappear beyond the event horizon and become unobservable. However, for an external observer at a safe distance from the black hole, this process would look completely different than it would for the astronaut falling into it. Because a black hole's gravity exerts a powerful influence on time, slowing its pace, an object approaching it appears to move slower and slower, as if freezing in time. Its light reddens and dims as it approaches the event horizon until it finally freezes at the edge and becomes virtually invisible. This creates a deceptive illusion that the object never crosses the event horizon, although it has long since disappeared behind it, becoming part of the black hole. Beyond the event horizon, in the region inaccessible to observation, space becomes completely distorted, and any trajectory along which an object moves leads only to one place, the singularity, which represents the heart of the black hole. The singularity is a hypothetical point in space where the density of matter and the curvature of space-time become infinite, which contradicts all known laws of physics. At least, that's what the general theory of relativity, developed by Albert Einstein, predicts. From the perspective of general relativity, all known physical laws cease to function at the singularity, and our understanding of the universe collapses. Space and time lose their familiar properties, and predicting what happens inside a black hole becomes impossible, which represents one of the main problems of modern physics. Some physicists speculate that, at the singularity, gravity may merge with quantum effects, creating phenomena that are currently beyond our knowledge and require the development of new physical theories capable of explaining the processes taking place. Although the black hole itself cannot be seen directly, we can study it through its influence on the surrounding space, manifested in various phenomena. Around it rotates an accretion disk, which is superheated matter consisting of gas and dust, which, under the influence of gravity, gradually falls into the black hole like water flowing into a drain. This accretion disk can heat up to millions of degrees Celsius, emitting powerful flows of X-ray and infrared radiation, which allow us to detect the black hole. Looking at the center of our Milky Way galaxy, we can mentally picture millions of stars swirling in a gravitational dance around an invisible overlord, obeying its insurmountable power. This object, called Sagittarius A, existed long before the appearance of Earth and our solar system, and it will remain here when our planet ceases to exist, continuing to influence the surrounding cosmos. But if single black holes possess such immense power and energy, what will happen when two such forces collide with each other, forming a cosmic cataclysm? What will happen when entire galaxies begin to gravitate toward each other, and their central black holes begin to interact, creating complex gravitational fields? The answer to this question may lie in the distant future of our galaxy, when it inevitably meets its closest neighbor, the Andromeda Galaxy, and a collision occurs that will change them forever. When we talk about a collision of galaxies, a catastrophic scenario involuntarily arises in our imagination, filled with chaos, destruction, and a whole chain of cosmic cataclysms, destroying everything in its path. But in reality, things will happen very differently, and the collision will unfold according to other laws. It will be a leisurely and majestic process that will stretch for billions of years and transform our cosmic home beyond recognition, creating a completely new type of galaxy. The Andromeda Galaxy is the largest galaxy neighboring us, and it is already heading towards us at a speed of about 400 kilometers per second, which is an incredibly high velocity. This speed is unfathomable by human standards, but on the scale of the entire universe, it represents only a measured and smooth flow of events occurring under the influence of gravity. Its diffuse disk, consisting of stars and gas, currently fills an impressive portion of our night sky, but in a few billion years it will become so vast and bright that the Andromeda Galaxy will dominate the night sky, becoming increasingly vivid and detailed over time. As the Andromeda Galaxy approaches, gravitational forces will begin to act stronger and stronger, exerting an increasing influence on the structure of our galaxy and its components. The spiral arms of both galaxies will stretch and distort, taking on bizarre shapes. Stars will begin to change their orbits, adjusting to new gravitational conditions, and interstellar gas will collide and compress, giving rise to waves of turbulent and intense star formation. During this collision period, millions of new stars, massive and hot, will ignite, illuminating the chaotically mixed clouds of gas and dust, creating a spectacular sight. However, the stars themselves will not collide with each other, since they are located so far apart that there remains a vast empty space between them, making collisions unlikely. If we could somehow survive this lengthy galaxy collision process while remaining on the surface of the Earth, we would not experience any immediate and drastic changes in our daily lives, which is an important point. But our night sky would gradually become completely different and transformed beyond recognition, which would be a breathtaking sight. Instead of the familiar canvas with dots of stars scattered across a dark background, we would observe huge glowing arcs and chaotically intersecting threads of gas, as well as frequent supernova outbursts adorning the sky. Approximately 4 billion years from now, the centers of the Milky Way and Andromeda galaxies will pass through each other, scattering thousands of stars in different directions, which will be the culmination of the collision. But gravity will not allow the galaxies to simply fly apart in different directions, and they will begin to converge again, performing several such oscillatory movements until they finally merge into one giant galaxy. This final merger process will take another 2 billion years, and eventually the chaotic debris will take on a new shape, a single, unified elliptical galaxy, different from both of the original ones. Scientists hypothesize that by this point, the supermassive black hole Sagittarius A, located at the center of our galaxy, may temporarily transform into an active galactic nucleus, exhibiting intense activity. Matter, captured by its gravity during the galactic merger, will begin to fall into the black hole at tremendous speed, triggering powerful ejections of energy and radiation. If this indeed occurs, then in the final stage of the new galaxy's formation, its center may shine like a quasar, a colossal and dazzling source of light, which will be visible from a distance of hundreds of millions of light-years, overshadowing all other objects. But what will happen to our planet Earth as a result of this collision? Since the collision itself will not lead to physical destruction or collisions between stars, our planet will remain in its orbit around the Sun and will not be flung into outer space, which is good news. However, unfortunately, in approximately 4 billion years, the Sun itself will become very different, and conditions on Earth will change beyond recognition. It will become approximately 30% brighter than it is now, which means that the temperature on the Earth's surface may exceed all critical values, making it uninhabitable. The oceans will evaporate, the atmosphere will turn into a dense shell of steam, and the surface of our planet will resemble modern Venus, where hellish heat reigns. If humanity finds a way to leave Earth and colonize other worlds by that time, it will be able to survive this grandiose cosmic event, watching the collision of our galaxy with Andromeda from a safe distance, which will be an unforgettable sight. Perhaps our distant descendants, if they still exist by that time, will see this collision of galaxies as a beautiful but distant spectacle, watching it from a great distance, already at the other end of the formed galaxy, or even far beyond it, in another star cluster. When this long and complex process of collision and merging of galaxies is finally completed, the familiar Milky Way will cease to exist in its previous form, giving way to a new structure. Instead of the two spiral galaxies that the Milky Way and Andromeda were, there will be one huge elliptical galaxy, different from both original ones, representing a bright, massive, and densely populated star system. Stars once scattered across different galaxies will reunite in a single structure, but in a completely new configuration, different from the previous one, mixed together. And even if the name Milky Way is forgotten over time, its stars will continue to exist, reminding of the distant past in this new and unexplored world, where everything will be different. And so, our fascinating and exciting journey through the Milky Way galaxy comes to its logical conclusion, leaving behind many impressions and new knowledge about space. During this journey, we learned how our galaxy is structured, what objects are in it, and how it all works. And we also tried to imagine its distant future, full of collisions and mergers with other galaxies. But even after all these discoveries and acquired knowledge, we clearly understand that the universe holds far more unsolved secrets and mysteries than we can imagine, and that we still have much to learn and discover. Every day, astronomers around the world are making new discoveries, expanding our understanding of the universe, and perhaps tomorrow we will learn something completely new that will forever change our understanding of the world and our place in it. Thank you for embarking on this informative journey with us, and we hope you found it interesting and educational. May the stars always shine brightly for you and illuminate your path, and may the boundless and mysterious cosmos always inspire you to new discoveries and achievements, making you strive for new knowledge.